everybody, and welcome to an AMPS experiment. We're joined with Carter. Hi, Carter.
Hey.
And we're going to be doing the Skittles and warm water experiment. This is a fun color experiment, bit of intro to chemistry, some talking about solutions and solvents, as well as color spread, sugar dissolvement, and a few other fun things. But most of all, this is a really fun project for seeing colors and color spreading and watching an exchange and velocity a little bit. So we're going to have Carter guide us through this experiment, and he is getting us set up. First and foremost, with every good science experiment, we need what, Carter?
Well, we need
a hypothesis, right?
Yes.
Yes. Say it really loud. Say hypothesis.
Hypothesis.
There it is. So we have a good hypothesis. What is your hypothesis in regards to what you think the Skittles will do?
Well, so the Skittles are going to be laid out all around the plate. I think once you pour the water on them, they're all going to come and mix together in the middle.
You think, okay, what color do you think it's going to make there in the middle?
Brownish, black.
That color you get where you like combine all the paints of the watercolor together, and it's really gross looking. Yeah. Well, let's see what happens, okay? So what we're going to do is I'm going to have you guide us through how to start this project, okay?
Okay.
So what's our first step?
You're going to take your Skittles.
Okay.
Put them out on your plate.
Okay. Do I want to put them in the middle, or do I want to put them out along the edge?
On the edge.
Okay. All right, so I'm going to go ahead and put my Skittles with my help here, who's not being so helpful. Are you doing a pattern?
No, I'm just putting them randomly.
You're just putting them randomly? Okay. How close are you putting them together?
Well, I'm kind of just like spreading them out, and then once I got like around, I'll fill in some of the gaps.
Okay. Oh, excellent. Are we going to put a lot of water or a little water in there?
It kind of depends.
Okay. So it depends on how big your plate is?
Yeah.
Okay. Now I can see I have about 1/8 of an inch of water in there, and I can see some things already happening to my Skittles. How about yours?
Yeah, things are happening all right.
What do you see got going on?
They're like kind of connecting up to each other.
Right. The colors are kind of spreading and then hitting each other, right?
Mm-hmm.
Then what happens after that?
They are just merging into each other.
Are they merging towards the center? Is it traveling towards the center of the plate, or is it moving outwards?
Very slowly, it's going toward the center.
Yeah. So are your colors combining? Are you getting that color combining that you thought you were going to get?
In this kind of area.
Now, why do you think over in that area compared to the other area?
There are a lot of purple Skittles.
Okay. Okay. Got a lot of the same color in that area, so it could be merging. What other reasons do you got?
I think maybe because more water got to this area.
Yeah. So depending on how much water you're going to get. Now, if you can you see mine where it's at, kiddo?
Oh, not right now.
Okay, I'll have to send Mom a picture. So I've got a little bit of color combining, but not as much as you do, because I didn't use quite as much water, which is completely normal. This is what we expect to see in a type of science experiment. Now, would you say your hypothesis of you had color combining was correct?
Not exactly.
Ah, okay. So not exactly. So your findings were partially right and partially wrong. What part was partially right?
This kind of area where it's like going and spiraling into the middle, and then it's just mixing
all those colors together.
And then this little part, I probably think because there is less water there, is just slowly just moving straight in.
You're getting that good color definition, right? So now, depending on what you were looking for, you could change this experiment up a little bit, right? Like if we wanted to see how much the colors combined and we wanted to see the swirling of the colors, we could do a lot more water, right? Versus if we wanted to keep the colors separate, we would do less water. Now, what I find interesting and on mine is I've got, this great green stripe by this purple stripe by this red stripe. And I can see on yours, you got a yellow stripe, a purple stripe, a green stripe, and a green stripe right next to you. Those colors are running pretty straight into the middle of the plate. Are you having some combining there, or are they keeping pretty well to their own lane?
Pretty separate.
Pretty separate. So if we used less water, would there be combining of colors in this situation?
Probably a little.
Yes, a little, but not as much, right? And that has to do with the melting of the sugar and the way the sugar absorbs into the regular water. So as the sugar is becoming a solution inside the water, it's moving more and more outwards. So that's actually what you're seeing, okay? That's one of the reasons why they don't combine as much, is the two sugars are thicker. They have a thicker, harder viscosity, and so they don't merge as well. So kind of think of it as like, have you ever spilled maple syrup on the counter? Like, yes. Have you ever accidentally spilled some maple syrup? And have you wiped it up and it was really hard to move it, but it's a liquid? That's because it's got a lot of sugar. It's a solution, so it's very thick with sugar in it. And that's kind of what we're doing. We're taking that hard candy shell and we're melting it down with that warm water to get a solution. Does that make sense? Mm-hmm. So now that you know that this does this, what could we do with this? What fun things could we do with this?
You can maybe try experimenting what it would be like to pour more water, pour less water.
Mm-hmm. Could we do patterns with our
Yes, you can.
Skittles and make like cool pictures? Mm-hmm. What would you do? I mean, I don't know how many do you have left, but what would it look like if you made a flower on your plate? Do you think it would look pretty cool?
Yeah.
Okay. What about, could you make a watercolor scene almost? So if you had like the green for the trees and the purple for the flowers, could you make kind of like a watercolor on your plate?
Maybe, but it'd be like some, like say a tree was supposed to be here, the leaves of the tree were supposed to be here. It'd probably maybe spread a little more than you
want it to. Your tree's way over there in the sky, right? So did you find this kind of fun? Would you want to do this again?
It was fun.
It was fun? Was it pretty easy?
This Skittle right now, it doesn't have the whole bottom half.
Yeah, and what do you see when you look at it?
It's like all white.
It's all white. So yeah, it ate through the entire candy shell. So we've dissolved the entire candy shell. So now you're looking at what's inside of a Skittle. Not so exciting, is it?
Yeah, the Skittle.
Right? It's red on the one side. It's white on the other side. Now that we have completed the experiment, we are going to talk a little bit about making this a little bit more chemistry driven. So you can use the term solvent for our warm water and solute for our Skittles, specifically the outside candy sugar coating around it. And what we are going to be doing with this is trying to make a solution. And what we are doing is adding our solvent to the warm water, to our solute, the Skittles, and creating it as solvent as it expands outwards. It's going to dissolve that candy coating shell, giving that solution slowly spreading throughout the plate. That's that rainbow stream that you're seeing come out of the Skittles. We could even term this an aqueous solution because this does include water in it. And please don't don't forget to include the hypothesis portion of doing these experiments. It's really important to ask that question of why. So from all of us here at AMP, we'd like to remind you to like, share, and subscribe, and join us for another bright idea from AMP Education.